Algebra 2 Honors, Lesson 5.5, Solving Quadratic Equations. Okay. Now in Lesson 5.4, we learned how to factor. Now in Lesson 5.5, we're going to learn how to solve a quadratic equation now. Okay. And here are the lesson's objectives, basically just to solve quadratic equations. And here are the guidelines for solving quadratic equations. Now the first thing I'm going to talk about is the zero product property. Right? Let's say we have if A times B is equal to 0, right? It would make sense that A is equal to 0 or B is equal to 0, right? Because we know anything times 0 equals 0. So if A is equal to 0, right, then the whole equation would equal 0, right? So if this was 0 right here, if A was 0, it wouldn't really matter what B is, right? B could be anything, right? We would still get a result of 0, okay? The same case for B, whatever A is, if B is equal to 0, it doesn't matter what A is, right? Our equation, right, when we multiply this, it's going to result in 0, okay? So if A times B is equal to 0, then we know either A equals 0 or B is equal to 0. Okay, this is considered the zero product property. Okay. Now, let's solve our first quadratic. So if we need to solve, let's see, we need to solve 2x squared minus 11x, right, is equal to negative 15. Okay. Now remember, the first step in solving is you have to make the equation equal 0, right? So we have to make this equation equal 0 first. So we're going to add 15 to both sides. That way we get 0 on the right side here. So then the problem becomes 2x squared minus, actually 11x plus 15 is equal to 0. Okay, so the problem is equal to 0 now. Alright, the next thing we're going to do now is, alright, is there a GCF? Factor out a GCF if you can find one. Remember, always look for a GCF first. Okay, is there a GCF? Well, it doesn't look like there is one. So what we're going to do next is we're going to make our x. Okay, I'll make the x over here, just like in lesson 5.4. Alright, to get this number is a times c. Remember, this would be our a value, this is our b value, and this is our c value. So a times c gives us 30. Alright, b is negative 11. So what multiplies to give us 30, right, and combines to give us negative 11. Well, it looks like negative 5 times negative 6. That gives us positive 30 if we multiply. If we add them up, it gives us negative 11. Now what's our a value? Our a value is 2, so we have to remember to divide both these numbers by 2. You cannot reduce this fraction, so go ahead and leave it like that. This one we can reduce, so this would reduce to negative 3 over 1. So our factors are going to be 2x minus 5, right, and x minus 3 is equal to 0. Okay, now let's think about the zero product property again. Alright, if we're multiplying these two factors right now, if this is equal to 0, it doesn't matter what this is, right? We're going to get a result of 0, right? If this is equal to 0, it doesn't make a difference what this is, we'll get a result of 0. So when either one of these factors equals 0, the whole problem will equal 0. Okay, so what we're going to do is we're going to take each factor, find out when it will equal 0. Take each factor, right, set it equal to 0. Right, go ahead and do the work, and you end up with x is equal to 5 over 2. And over here, x is going to equal 3. Okay, now I'm going to show you something really cool, right, that'll save you a lot of time and work. Okay, if you take a look at our answers right here, you'll notice, right, if you compare them to these fractions that we had generated earlier, right, you notice they're the same thing, except that they're opposite signs, okay? That's what's really cool about the X method, right? When you're solving an equation using the X method, once you get to right here, you can actually skip all this extra work in the middle right here, because you know if you just take the opposite signs of these numbers, those will be your solutions, right? That's what X will be, okay? So you notice, so if I got to right here, negative 5 over 2, I know I could skip all this and say X equals 5 over 2. Right? If this is negative 3 over 1, that's the same thing as negative 3. So I know I can say X is equal to the opposite of this, so it would be 3. And skip all this extra work in the middle. Okay? If you want to, you can always, set up their factors and set them equal to 0, just to be, on the safe side. Right? But basically take these opposite signs and you're done. Okay? So let's solve another one. So we need to solve x squared plus 7x is equal to 18. Right. Remember, the first step in solving, the problem has to equal 0. So we're going to minus 18 here, minus 18 here. That eliminates. We're going to get x squared plus 7x minus 18 is equal to 0. Okay. Is there a GCF? Nope, it doesn't look like there's a GCF. So let's make our x. All right. Pretend there's a 1 here. A times c, that gives us negative 18. Right. The middle is positive 7. So what multiplies to give us negative 18 and combines to give us positive 7? Well, it looks like 9, right, and negative 2. Do these multiply to give us negative 18? Yep. Do they combine to give us positive 7? Yep. And what's our a value? Our a value is 1. So let's divide by 1. Now since we're solving, right, I asked you to solve, right, and then like I said before, once you find these fractions right here and you've reduced them as much as you can, right, all you have to do is take the opposite signs. So you know x is going to equal the opposite of this, so that'll be negative 9. And x is going to equal the opposite of this, so that's going to be positive 2. And then you're done. You've solved the problem. Right? You didn't have to do any of that work in the middle. Right? That's what makes the X method, right, so cool. Alright, let's do another one. Let's see, we have 2x squared plus 4x is equal to 6. Well, we've got to set the problem equal to 0 first. So we're minus 6 here, minus 6 here. So we're going to get 2x squared plus 4x minus 6 is equal to 0. Alright, is there a GCF? Alright, always look for a GCF, don't forget that. So, well, there is a GCF, we got to take out a 2. That'll give us x squared plus 2x minus 3 is equal to 0. Now we're going to try and factor this using the X method. Right. Now right here, right, what a times negative, right? The a value is 1, so 1 times negative 3 is negative 3. Right, the middle value is 2. Alright, so what are our factors going to be? Well, it looks like it's going to be 3 and negative 1. These multiply to give us negative 3. They combine to give us positive 2. What's our a value? Our a value was 1, so let's divide these by 1. So our factors, alright, you can set them up if you want, or just go to the shortcut. You know, it's going to be the opposite of this, so that'll be negative 3. And x is going to equal the opposite of this, which would be positive 1. Now you have to be careful. The GCF here, since it was only 2, since it was only 2 right here, there's nothing for you to worry about. But let's say, for example, if there was an x out here, you would have to take 2x and set it equal to 0. Okay? And I'll show an example of that next. Okay? So, now let's say you had factored out a problem, and let's say there was 3x, right? And then we had x squared plus 5x, right, plus 6. Okay, let's say, and then you have to use the x to factor this, right? So the a value is 1, 1 times 6 is 6. Alright, we're trying to get 5 in the middle, so it looks like 2 and 3. Alright, we're dividing by the a value, which is 1. So we know x is going to equal the opposite of this, negative 2. And x is going to equal the opposite of this, negative 3. Then you have to remember, since out here there was an x with this number, alright, since there was an x, you have to take 3x and set it equal to 0. Alright, so you divide by 3, then you'll know that x, alright, is equal to 0. So this is also a solution. So x, alright, is also equal to 0. Okay, so if there's an x out here with the GCF, alright, you've got to take this, alright, term and set it equal to 0. Okay, so here you go. Okay. Alright, the next type of problem we're going to solve is solve 5x squared minus 180 is equal to 0. Okay, well the problem equals 0 already. Alright, so that's fine. Okay, now next thing we're going to take a look at is, well, is there a GCF? Well, it looks like we can take out a 5. We'd end up with x squared minus 36 is equal to 0. Okay? Then you have to recognize, what is this right here? This is a difference of squares. So we can factor this, right? So you remember the pattern for factoring difference of squares. You know right away you're going to get x plus 6, x minus 6 is equal to 0. And then take each one of these factors, set them equal to 0. X plus 6 equal to 0. X minus 6 equal to 0. So then we know x is going to equal negative 6. Right? And x is going to equal 6. Now since this was only a 5, we can ignore this because there was no x out here. Okay? So we know this would be our solution. Okay. Now another way, another way to solve this, is a method called taking square roots. Solve by taking square roots. Solve by taking square roots. And sometimes you will have to use this method, sometimes you won't. For this problem, we could solve this way because we were able to factor this. But sometimes when this is not factorable, you will have to solve by taking square roots. Okay. Now if you're solving by taking square roots, so let's say we have the same problem again. If you're solving by taking square roots, what your goal is to try and get the x squared by itself. Okay, so basically you would have to add 180 to both sides. So you would get 5x squared is equal to 180. And since we're trying to get x squared by itself, we're going to divide by 5. We get x squared is equal to 36. Now, since we have x squared here by itself, now remember our goal is to find out what x equals, so you need to get rid of the exponent here. In order to do that, what you're going to do is you're going to square root both sides. And you have to remember, when you square root both sides, that'll leave you with the x, which is what you want. Anytime you square root both sides, you're going to have a plus and a minus on the other side. So this will give you x, so it'll be x is equal to plus or minus some answer. So don't ever forget the plus or minus. So when you square root both sides, to get x by itself, you're going to have a plus and a minus. Well, what's the square root of 36? That'll give you 6. And you notice we get the same answer right here. So x is equal to positive 6, and x is equal to negative 6. The same answer. Okay? So just a different method, but it gives you the same answer. So when you're able to factor this, because it's a difference of squares, go ahead and work it out this way. But sometimes when it's not factorable, you will have to solve using the square roots method. Okay, and we'll do an example of that next. So solve let's see, 3x squared is equal to 24. Okay, well the first thing you might want to try to see is, well, is it possibly maybe a difference of squares? So we would set the problem equal to 0. So you get 3x squared minus 24 is equal to 0. If you take out the GCF, you get 3 times x squared minus 8 is equal to 0. Then you recognize, wait, this is not a difference of squares, so I'm kind of stuck because I can't factor this using a special pattern. So then that's when you know you have to solve it using the taking square roots method, right? Taking square roots method. Right. So since this was not factorable, you're going to solve it using the taking square roots method, which means, alright, we'll start with this problem again. The taking square roots method, you're trying to get x squared by itself. Okay, so let's divide both sides by 3. So then you get x squared is equal to 8. And then we're going to square root both sides because we want x by itself. Now remember, when we square root both sides, we're going to have a plus and a minus. And what's the square root of 8? Remember, simplify this. Right, that's going to give us 2 radical 2. So we know x is going to be positive 2 rad 2, and x is going to equal negative 2 rad 2. Alright, so these would be our solutions. Okay, so when this is not a difference of squares, okay, we're going to have to use this taking square roots method. Okay. Alright, let's solve. Let's see. 16x squared is equal to 8x. Alright, well, let's try and solve using factoring method first. So we will minus 8x to both sides. You'd end up with 16x squared minus 8x is equal to 0. Take out the GCF, but we could find one. And the GCF would be 8x. That'll leave us with 2x minus 1 is equal to 0. Alright. Now, even though this is not a difference of squares, it's already completely factored because it's not an x squared. Right? So this is factored out already for us. Right? So we're going to take each factor now. 8x, make it equal 0. Take this, 2x minus 1, set it equal to 0. So if we divide by 8, x will equal 0. Over here, we're going to add 1. So 2x will equal 1, divide both sides by 2. So x is going to equal 1/2. So these would be our solutions right here. Okay. Alright, so to summarize, alright, you always want to try and factor a problem as much as you can. Alright, this is completely factorable, so just take the factors, set them equal to 0. Okay. If you get a problem such as this, let's say for example, 3 parentheses x squared minus 20 is equal to 0. If you get something like this after you've tried to factor, then you know, well, you have to solve this using the square roots method. Okay, because since you can't factor this, you have to solve it using the square roots method. Okay, so let's say the original problem here would have been 3x squared minus 60 is equal to 0. So if you're going to solve 3x squared minus 60 is equal to 0 using the square roots method, you have to try and get x squared by itself. So you would add 60 to both sides. So you get 3x squared is equal to 60. Divide by 3. So x squared is equal to 20. And then when you square root both sides, that'll give you x by itself is equal to, remember we need the plus or the minus, and then square root of 20, that's going to give us 2 radical 5. So x would equal 2 radical 5, and x is going to equal negative 2 radical 5. Okay?